Hello, today our goal is to rewrite logarithmic expressions and exponential expressions. We're going to be expanding and condensing logarithms. So logarithms have properties, and their properties are going to mimic your exponent rules because the answer to a logarithm is an exponent. So let's go ahead and take a look at A, B, and C real quick, and then we'll look at how that applies to the properties of a logarithm. If you had x squared times x cubed, when you are multiplying two exponents with the same base, you look at this and you say, hey, that's going to be x to the fifth because I take and I add my exponents together. If I'm dividing, I say, hey, that's going to be x to the fourth because I take and I subtract my exponents. If I have an exponent raised to a power, you take that and you multiply it. And so looking at these ones, that's going to apply directly to your properties of logarithms. So if you have two logarithms that are being added together, notice again they have the same base just like your exponents there. They had the same base. If you have two logs with the same base and they're separated by addition, that means you can write them together. They were being multiplied together. So just like above, when these two were being multiplied together, we actually added them. So the next one is going to follow suit, but with division. So if you have two things that have the same base, if it is division, that's really going to stand for subtraction. And the reason being is because this exponent of the one in the bottom has to be a negative exponent because it's being divided. So that actually is why V has the negative out in front to show that's what was in the denominator. And then the last one here, notice we have a power, something being raised to the power. That's going to be multiplication, and the way we're going to show that multiplication looks a little bit weird. We're going to bring that exponent that was up as your exponent, and we're going to be bringing it in front to show the multiplication. That's where this is coming. So now that we know these different rules, let's go ahead and take and apply them. We're going to be expanding and condensing. So what we'll do is we'll go ahead and do number one together, and then we'll work on a couple more expanding ones, and then we'll come back to number two. So if I have something that is one logarithm, so look and notice that this is log base 2 of all of this stuff here. What I'm going to do is I'm going to figure out how many different things I'm taking the logarithm of. In other words, how many different bases do I see inside of my logarithm? So I see something that's a 4, so that's a base of an x, a y, and a z. So that's how many different terms are inside my logarithm. That's how many times I'm going to write my logarithm. So I'm going to do log base 2, and I'm going to give myself some space. I'm going to write out 4 of these. Okay? Then each thing inside of my logarithm, so the 4, the x squared, the y, and the z squared, each of those is going to get its own logarithm. Okay? So we're going to do the 4, the x squared, the y, and the z squared. So every different term inside of the logarithm gets its own log. And now looking at this, what we're going to do is we're going to figure out which of these are in the numerator and which ones are in the denominator. So anything that was in the numerator is going to have a positive exponent. So therefore, it's going to be a plus sign in front of it. So log base 2 of 4 is positive. The x squared is positive exponent. Anything inside of the denominator has a negative exponent. So the coefficient for those ones are always going to be the negative. So if I look at this written out, I can see that the 4 was in the top, the x squared was in the numerator, the y and the z squared were in the denominator, just based off of their signs out in front. Okay, so that's the first step of expanding, is writing out all of these as different logarithms. Then you need to figure out anything else that can continue to simplify. So with numbers, you have to see, can I simplify that number? And then the other thing is anything that's an exponent also has to be simplified. So let's go ahead and think about log base 2 of 4 first. I'm going to give myself a little bit of space here, and I'm going to kind of enter the exponential world to help me figure this out. So this is saying 2 to what power gives me 4 as my answer. And so looking at this, you would say, hey, 2 to the second power equals 4. So the answer to this logarithm is the exponent. So log base 2 of 4 is 2. My next term, I said there's something to simplify here because we still have that exponent. So the exponent, as a reminder, is going to come out in front and be written as multiplication. So this is 2 log base 2 of x. The next one here, minus log base 2 of y. Nothing simplifies. And then the last one, this 2 also comes out in front. So it's minus 2 log base 2 of z. This is the expanded form of my initial problem there. So let's go ahead and take a look at a couple more that we want to expand. We're going to use that same method. Number 3, we're going to take and write 1, 2, 3 different logarithms because I see 1, 2, 3 different terms. So I have log base 3 of the x squared. I have log base 3 of 9. And I have log base 3 of y cubed. Then for each of these, we have to figure out if they're positives and negatives. Anything in the denominator has a negative exponent, so those ones are the minus signs. And now we have to figure out what can be simplified. So we're going to go problem by problem. This first one has that square. So we're going to bring that square out in front and write it as log base, or 2 log base 3 of x minus the log base 3 of 9. Anything with numbers, ask yourself, can that actually simplify it all? So we have to figure out if we can solve 3 to some power equals 9. That one does work. 3 squared equals 9, so that's going to be a 2. And then the last one also has an exponent, so exponents have to come out in front. So we're going to write minus 3 log base 3 of y. This would be our expanded form for number 3. Let's go ahead and take a look at number 4 then. Same idea. I see 3 different terms, so I'm going to write log base c 3 different times. So log base c, one is for the 3. Log base c, one is for the b squared. And log base 3 for the square root of x. There is no denominator for this one, so all of these are actually positive, so you're going to have a plus sign for each of them. Now looking at this, there are actually 2 that we have to simplify farther. The first one would be this b squared. The other one is this square root of x. This is kind of a stealth mode one. This square root of x is actually x to the 1/2 power. It didn't look like an exponent, but it actually is an exponent when we take and write it as just the base of x. So to simplify further, this first one nothing happens, log base c of 3. This next one, we bring the 2 out in front, and we get log base c of b with a 2 out in front. And the third one, we bring the 1/2 out in front. So it's log base 3 of x. So those are our expanding rules. Now what we're going to do is imagine we have all of these, and we're going to take and we're going to work backwards. So we're going to be given the answer basically, and we're going to have to condense it, smush it together into one logarithm. So let's take a look at number 2 here. We're going to go backwards. So the first thing I notice here is that there's a 4. So this 4 here used to be an exponent. So I'm going to move it back up to the exponent. So this actually would be log base 2 of y to the 4th power. The other thing I notice is that there's this 3 here. We have to deal with this 3. So here's my recommendation with a whole number like this. When you have that whole number, what I want you to do is I want you to take that log that you have, log base 2, and I want you to write whatever the base is inside the logarithm. Okay, so log base 2 of 2. And so this log base 2 of 2 is really just 1. So 2 to what power equals 2? It's just 1. So what I've done is I have written something that doesn't change the value. I'm just changing the way this looks because now this has a logarithm. Now I can actually work with this. So I'm going to take this 3 that was already there and I'm going to put it up as my exponent. So this becomes log base 2 of 2 cubed. And so that is log base 2 of 8. And so then I'm going to continue bringing down everything else that I had, log base 2 of x, log base 2 of y to the 4th. Now I have everything that I can combine because I see log base 2 for every problem. So I am going to write log base 2 just once. And then I'm going to plug everything in. This 8 is positive out in front, so it's in the numerator. This x is positive out in front, so it's in the numerator as well. And this y to the 4th is also positive, so it's in the numerator, so there's nothing in the denominator. This would be everything condensed together. And here's the great news with this. You can definitely seesaw on this, and whatever you just did, undo it. So take log base 2 of 8xy to the 4th and see if you can expand that out. You should end with what you started with. Let's go ahead and take a look at a couple more examples here. So we are going to go ahead and condense these into a single logarithm. So for number 5, I noticed that this 2 is out in front and it needs to be written up as an exponent. And then everything else is actually ready to go already. So we have log base 2. This one I see 2 minus signs. So I'm going to go ahead and write a fraction because I know those are going to go in the denominator of my fraction. The x is going to go in the numerator because there's a positive out in front. The y and the z squared are in the denominator. Okay, for number 6, we're going to do the same thing. I see this 1/2. It's going to go up as my exponent, so this is x to the 1/2, or the square root of x. Okay, so that's going to be log base 3 of the square root of x. This 1 out in front is a number, so I'm going to have to do that strategy we were talking about earlier. I'm going to leave the 1. My base of this problem is 3, so I'm going to write log base 3 of 3. Then I'm going to take the 1 and I'm going to bring it up as my exponent. So I get log base 3 of 3 plus log base 3 of the square root of x minus log base 3 of y. Now all of these have the same log base 3. Now I can combine them all together. So it's log base 3. I do see a minus sign, which means it's going to be a fraction. The 3 and the square root of x are in the numerator, and the y is in the denominator. And as well, you can take both of these answers and try to expand them and see if you get what you started with for those ones. Okay, so I'm going to ask you to actually pause the video now and try 7, 8, 9, and 10 below. So go ahead and pause it and try the examples below. Okay, now that you've tried these, here are the answers to them. So for number 7, there were 1, 2, 3, 4 different terms. So we had to write 4 different logarithms, and we had to evaluate anything that had numbers and bring down anything that had exponents. So we end up with this as our final answer. For number 8, we had this number to deal with, the 2. So anytime you have a number, you take the log with the base of the problem, and you use that number inside the logarithm, and then you move your coefficient up as your exponent and put them together to give us this as our final answer. And then for our last 2, let's take a look at here. We once again had a coefficient for number 9, so we had to do the same thing, steal log base 4, and then plug a 4 in and move that 2 up. There were 4 different terms. 2 of them went in the denominator because of the negative exponent. And then for number 10, we had to expand this one because it was one logarithm. There were 2 different terms inside that logarithm, so we wrote it out as 2 terms and evaluated the numbers and brought down the exponents. Thank you very much for listening. I hope this helped. Have a good day.